We want to factor each expression by any method. So since 5 and 6 are already X box drawn, I'll do those that way. So we want to check for GCF. So I'm going to write that here. No, I'll write it off to the side. So our GCF for this one, they don't have an X in common, they don't have a number in common, so our GCF is 1, which doesn't change anything about this. So our A is 1, our C is -5, or -15, sorry. So that gives us -15 on top. That gives us a 2 on bottom. Now we're looking for a difference, so I know one's going to be positive and one's going to be negative because that is negative. So things that multiply to 15 and add to 2. Let's go 5 and 3. So I get x squared minus 15 positive 5x and a -3x. Then our GCF, so that is 5 there. That is x there. That is x there. And then here we get a 3. And then double check x times 3 is +3, but I need a negative. And then -3 times 5 is a -15, so that works. So then this factored out is x plus 5 and x minus 3. Okay, so let's look at 6 now. So is there a GCF? It looks like a 3 can go into all of them. And then so that leaves me with 3x squared minus 10x plus 25. So then our A is now 1. Our C is 25 because we're using that new one. So this one goes away and we're now using this here. So that's 25 on top. And then our B is a -10. So as we check that, since this is positive, we know both these signs are the same, and that's negative, so those are going to be negative. And multiply to 25 and add to -10 is a -5 and -5. Now I'm again just dealing with this, so I get x squared and 25 here. -5x squared, -5x squared. Or sorry, not x squared, just x. Factor out, that gives me a 5. Factor out, that gives me an x. We go this way, that gives me an x. And then we go this way, that gives me 5. Now as we double check, x times x is x squared, that's good. X times 5 is +5, but we need negative, so I'm going to make this a -5. And then -5 times 5 is -25, so I need to make that one negative. X times -5 is -5x there, so we're good. So make sure we double check, especially when there's negatives. Those negatives will end up out there, but double checking always works. So then we get x minus 5, x minus 5. And if we left it at this, we'd actually lose a point even though we did all the work. Do not forget that GCF. So then the fully factored answer would be 3x minus 5 times x minus 5. All right, let's look at 7. So then my A is 7, my C is -8, so that's a -56, and then my B is a -26. And so as we look for factors, and then since I know that this is negative, these are going to be opposite, so I'm looking for the difference. So I have 1 and 56. Well, that's a difference of 55. That doesn't work. I have 2 and 28. It's a difference of 26, so that works. And I want -26, so -28 is going to go there. 2 is going to go there. And then as we do our grouping, we get 7x squared plus 2x minus 28x minus 8. Then we group. Here we have just an x in common. That leaves us with 7x plus 2. Here we have that negative that we're going to pull out. And then we have a 4 in common. And that leaves us with 7x plus 2. Then we have 7x plus 2 in common. So I pull that out. And we're left with an x and then a minus 4. All right, let's look at number 8. And so our GCF, which I forgot to do on the number 7. So our GCF on number 7, as we look at this one, is just going to be 1 because x's aren't in common. Nothing goes into 7, 26, and 8. So as we look at 8, we have a GCF of 2. So that now gives us a 2y squared plus 7y plus 3. And then this will factor. My a is 2, my c is 3, so that is 6. My b is 7. Multiplies to 6 and adds to 7 is 1 and 6. So then we get 2y squared plus 1y plus 6y plus 3. And then group. Here we have just a y in common, so that gives us 2y plus 1. Here we have a 2 in common. Oh, sorry, not a 2. A 3 in common. That gives us 2y plus 1. There's our 2 y's that are in common, so we can factor that out. And then we're left with y plus 3. All right, your turn to do 9 through 12 there. Work on those. We'll discuss those when we come into class. All right, now this definition of prime means it's in its simplest terms and it is unfactorable. Okay, that includes GCF, Xbox grouping. We can't do any factoring to that. So as we look at 13, our GCF is 1, which doesn't do anything, so that is still unfactorable. And then let's look at our x. So a is 1, c is -8, b is -4. Is there anything that multiplies to -8? Well, we have 1 and 8. We're looking for a difference. Well, that's 7. We have 2 and 4. Well, that's 2. 3 doesn't go into it, and then once we get to 4, that goes to 2, so it doesn't matter. So then this one is what we would call prime. The only thing it had in common was a 1. We couldn't Xbox or group it, so then that one is called prime, meaning it's unfactorable. All right, let's look at 14. A, is there a GCF? Always our first step. So is there a number that goes into 6, 26, and 10? There is. It is 2. That leaves us with 3x squared plus 13x minus 5. Now, if we're just looking to see if it is prime at this point, we factor out a GCF, so it is no longer prime. If we wanted, we could go ahead and factor this further. So 3 times -5 is a -15, and then we get 13 here. Since this is negative and this is positive, and we're looking for a negative and a positive, my biggest is positive, so for 15, we have 1 and 15. Well, that has a difference of 14. That doesn't work. And then 3 and 5, that has a difference of 2. That doesn't work. So there is nothing. So then this ends up being our answer, which is factorable because we factored out a GCF of 2. All right, you have your quizzes, and then our essential question of how can ax squared plus bx plus c be factored.